Module 1. Footwear Performance and Comfort. Unit 1. What is comfort in footwear?
Lecture 1.1. The concept of comfort. This lesson is structured as follows: definitions and concepts. Evaluation methods, subjective, objective.
The concept of comfort today.
What is comfort in footwear? Introduction, definitions and concepts. Considerations for footwear materials. Evaluation methods. Provide information about whether a shoe is comfortable or not.
Objective. Subjective. Relation between subjective and objective.
Comfort definition.
Comfort is defined as a subjective feeling that describes an individual's well-being condition, which is also associated to everything that provides individuals with what they consider as comfort and well-being values. In the specific case of footwear, two comfort levels can be differentiated: immediate comfort, which is associated with the moment when the shoe is tried on, and deferred comfort, which is linked to its daily use. These two comfort levels affect both the purchase decision and the use of footwear. With respect to the purchase decision, immediate comfort takes place when the shoe is tried on for the first time and the user walks a little bit around the shop, in the case of a traditional purchase in a physical shop, not in online purchases, and deferred comfort intervenes in decisions of future purchase of the same model and/or brand, product and/or brand loyalty.
Conclusion.
Comfort is becoming a priority objective for footwear manufacturers, hence the importance of a correct prior analysis of footwear comfort. It affects not only the purchase decision but also the functional performance of footwear and, therefore, the user's health. The sum of all factors makes it extremely difficult to quantify footwear comfort in a single test with a single variable. Therefore, it is essential to implement a test method based on a protocol that consolidates the procedures and establishes similar conditions for data collection with the aim of promoting a common framework for the realization of comparative studies on the degree of comfort provided by a given shoe.
Key factor in footwear comfort.
Footwear comfort has a widely recognized role. Scientific and technological developments allow the design and manufacture of shoes to offer high levels of comfort and safety. Footwear is designed to fulfill a variety of purposes that must meet three criteria: form, function and fit.
The shape is related to the aesthetic appeal of the footwear, the function is related to the ability of the footwear to fulfill its intended purpose, how to protect the feet, and the adjustment refers to how the footwear can adapt to the morphology of the foot.
Comfort factors. Toe box allows normal foot function for the individual. Sole does not interfere with normal foot function. Softness and flexibility of upper and lining surfaces of shoe. Stable heel of suitable block height of approximately 25 mm. In shoe climate that promotes a healthy environment within the shoe. Shoe must not noticeably slip on the foot. Outsole grip standards.
Properties of a comfortable shoe: flexible, protecting against slipping, good absorption of impact energy, light, cold insulation, proper fit, functionality, adequate pressure distribution while walking.
Footwear comfort assessment.
Evaluation methods: subjective, objective. To evaluate the design of a shoe, the available tests can be classified into two classes: subjective tests and objective tests.
Both analyses provide useful information to evaluate the comfort and functionality of the shoe. However, they do not guarantee comfort for any user and, in addition, the equipment, instrumentation and personnel needed to complete them are expensive in time and money. The objective tests are based on measures of biomechanical variables during the use of shoes in real and simulated conditions. Objective tests provide useful information for the evaluation of footwear functionality.
The subjective tests are based on the perception of the user and are essentially tests of comfort and wear tests of prototypes of shoes by people, based on comfort surveys carried out on users. Functional analysis deals with the study of the coexistence between foot and shoe in a real situation. The equipment, biomechanical instruments and personnel needed to perform these tests are expensive and time-consuming. An alternative to these procedures is the use of virtual reality and simulation techniques. With a virtual simulator that performs comfortable shoe tests without having to make the real prototype and without having to use people, the temporary and economic costs involved could be considerably reduced.
Functional analysis applications to assess footwear comfort.
Footwear comfort is also relevant as a conditioning factor for the biomechanical aspects related to the development of lower limb activities and, therefore, also affects users' well-being, going beyond a subjective feeling. Footwear comfort has a widely recognized role in several functional aspects, such as gait kinematics and kinetics, neuromuscular control of balance and posture, muscle energy expenditure. Researchers in the medical and biomechanical fields have their attention to problems of comfort. However, few investigations have focused on evaluating the analytical correlation between subjective and objective responses.
Comfort functional aspects and comfort feeling.
With regard to the specific factors affecting footwear comfort feeling, the scientific literature includes numerous studies on the relation of footwear comfort with muscle activation, foot sensitiveness, plantar pressure distribution, vertical impact force, movement of the rear foot, foot and leg alignment and their shapes, and the physical properties and manufacturing characteristics of footwear. The latter including those of the materials making up a shoe. Although comfort is a subjective measure, some studies have tried to relate objective measurements, such as the characteristics of the shoe interface, with perceived comfort. It was observed that physiological responses, such as plantar pressures, are strongly related to physical parameters such as materials and plant form.